Welcome to the Explainer. So, if you're an engineering manager right now, you're likely staring down a massive, honestly, unprecedented challenge. You're trying to scale AI-assisted development tools across your whole org. And hey, it's exciting, it's moving incredibly fast, but let's be real. It's also creating a totally new category of headaches. Today, we're unpacking a really fantastic piece of research from Meneme HQ called Prompt Engineering is Not Governance. It gets right to the heart of why so many of us are struggling to keep our code bases clean and consistent as AI output just completely explodes. So it's the million-dollar question, right? How do you actually ensure AI respects your team's hard-won architectural decisions? The intuitive industry instinct, absolutely the most common answer we're seeing right now, is to just stuff all those architectural rules right into the AI's prompt. Just tell the AI what not to do. It sounds logical, right? And, it even kind of works for a little while. But as the source material points out, it ultimately structurally fails. Today, we're going to look exactly at why that instinct is flawed and what you actually need to be building instead. Okay, let's dive into this. Here's our roadmap for today. We'll start by defining the AI governance gap. Then we'll validate the strengths of prompt engineering. From there, we'll look at where prompting structurally fails, examine the session boundary problem, and finally, outline true architectural governance. All right, part 1, the AI governance gap, conflating generation with enforcement. Now, what's really interesting about this slide is how it draws a hard architectural boundary between shaping behavior and enforcing hard rules. This conflation between generation and enforcement is literally the root cause of the biggest mistake teams make when governing AI at scale. Look, on the left, we've got prompt engineering. The research strictly defines this as a generation technique. It shapes the output. On the right, governance, which is an enforcement architecture. Shaping behavior and enforcing decisions are simply not the same thing. Treating them like they are creates this massive governance gap. And here's the kicker. This gap usually only surfaces when something goes really wrong. You could write the most precise, totally exhaustive system prompt imaginable, but it's still going to fail to enforce your rules. Why? Because enforcement can't be delivered by a text instruction to a language model. It's an architectural problem, not a prompt quality problem. Moving on to Section 2, the strengths of prompt engineering and validating the tool. Now, I want to be super clear here, and the source material is explicit on this too. Prompt engineering is absolutely not useless. It has genuine strengths, and it's an absolutely essential layer in your AI coding workflow. Walking through this direct comparison, you can see it's brilliant for shaping output style, tone, and verbosity. It's perfect for nudging the model toward preferred idioms and giving task-specific context, like pointing out which file to edit or what good looks like. These are real, powerful capabilities. The mistake isn't using prompt engineering, the mistake is relying on it to substitute for constraint enforcement. You just can't expect it to remember things across sessions or resolve complex rule conflicts. It just wasn't built for that. Section 3, where prompting structurally fails, the 5 failure modes. We need to shift gears for a second and get deeply analytical here. Because as engineering managers, you really need to understand that these failures aren't happening because your team is writing bad prompts. Actually, they're structural properties of how language models process instructions. The research lays out 5 specific things prompt engineering fundamentally cannot do. It cannot enforce constraints, resolve conflicts, scale across agents, survive context window pressure, or provide an audit trail. Let's break each of these down, because honestly, this is the ultimate reality check for anyone relying solely on prompts to keep their codebase safe. First up, enforcement. Think about it. A prompt is fundamentally just a suggestion. The model weighs your prompt against every single other signal in its context window, the task description, the retrieved code, those inline comments, and then it makes a judgment call. The source points out a crucial dynamic here. When the model is trying to complete a task and your constraint creates friction, task completion wins almost every time. The AI will reason right around your suggestion. You literally cannot turn a suggestion box into a brick wall just by writing better suggestions. Second, conflict resolution. Let's say you have an org-wide rule, but also a team-level exception sitting in your system prompt. How does the model pick? Well, it picks based on proximity and weight in the context. There is no precedence hierarchy in a language model. There's just text. Deterministic conflict resolution requires an explicit precedence model. And third, scaling across agents. Every tool, every integration, every team usually maintains its own system prompt. The source gives a great real-world scenario. Your payments team's agent knows completely different rules than the analytics team's agent because the prompts drift over time. Without a single authoritative source of truth, prompts diverge and your governance just shatters. Fourth, context window pressure. This is a brilliant quote straight from the text. Your rules get quieter as the session gets longer. In those long-running agentic sessions, the context window just fills up with conversation history, tool outputs, and reasoning steps. Because of how transformer attention allocates weight, those crucial system rules you injected right at the very beginning get measurably deprioritized by the middle of a long run. It's not a bug, right? It's just the architectural reality of the context window. And fifth, the audit trail. As an engineering manager, if an architectural violation slips into production, you need to know why. But with prompt engineering, there is zero record of which rules were actually active when that file was written. You don't even know if the rule was in the prompt when the violation occurred. Debugging governance failures after the fact requires reconstructing the entire session, which the source notes is practically impossible. Without a structured decision record, you have absolutely no audit trail. All right, Section 4, the session boundary problem. Why models cannot accumulate institutional knowledge.
So there's this very specific invisible wall in AI development that causes models to suffer from total amnesia. It's called the session boundary problem, and this brilliantly illustrates how the model starts completely from zero every single time. It possesses absolutely no memory of what it decided an hour ago. It is completely blind to the architectural violations your team caught in last week's PR reviews, and has no clue what you ratified in that postmortem last month. A language model simply does not accumulate institutional knowledge.
Because of this amnesia, your prompt templates have to be re-injected every single session. But what if the template isn't updated? Or what if two engineers on your team are using different tool integrations that inject slightly different system prompts? Suddenly, they're operating under stale, conflicting rule sets without anyone even knowing it. The big takeaway here is that the session boundary is the governance boundary, and prompt engineering has absolutely no mechanism to bridge it. Section 5. Let's move to and see how this builds into true architectural governance and the blueprint for enforcement. If prompt engineering is just a complement to governance, what does true architectural governance actually look like? Well, the source outlines a specific blueprint. Effective enforcement requires 4 architectural properties that operate completely outside of the language model's prompt. First, a structured decision schema, meaning typed fields for scope, status, and the constraint itself. Second, a precedence engine for deterministic resolution when rules inevitably overlap. Third, scope-aware retrieval, so the right rules fire for the right files rather than just relying on fuzzy semantic similarity. And finally, hook-level enforcement. This means violations are blocked at the source, right before the file is written or ever hits PR review, which is absolutely crucial for saving your senior engineer's sanity and keeping your CI/CD pipelines from lighting up red. So the crucial point is this. True governance requires a completely separate structural layer. It's a distinct system that intercepts the generation events from your AI, resolves applicable constraints deterministically, and actively flags or blocks violations. Look, no prompt, no matter how exquisitely crafted, can substitute for this dedicated structural enforcement layer. Relying on prompts is definitely easier in the short term. But as the source warns, the cost of that gap becomes painfully clear right after your first major architectural violation. I want to leave you with this final provocative thought. Take a hard look at your team's current AI implementation. Are you trying to enforce hard architectural rules with what is effectively a suggestion box? Because if your governance relies on hoping the AI remembers a text prompt during a long session, you don't have governance, you have a wish list. It might just be time to rethink your systems design and start building true enforcement infrastructure. Thanks for joining me on this explainer. I hope this helps you and your teams scale safely.